The top 7 most unusual structures in the universe. Let's find out what they are. Number 7. Swift J1357.4. Swift J1357.4 is about 5,000 light-years away in the constellation of Virgo. It's the only object really found in our galaxy that can be seen from Earth. The structure is one of the least understood on this list. Scientists think it is made up of a star and a black hole with the mass of a star. The system's partner star goes around the system's mass in 2.8 hours, which is the shortest orbital period that we know of at this time. Black holes are not cosmic vacuum cleaners that eat everything around them, despite what most people think. On the other hand, black holes only eat things that are close to them, dropping within the event horizon, which is the point beyond which nothing, not even light, can get out. When something, or a group of things, is in a safe orbit around a black hole, gravitational disturbances can cause it to go off course and spiral inward. So it's not unusual for there to be more stuff around than the black hole can eat at any given time. It is known that this material can build up and form an accretion disk. Most likely, Swift J1357.4 is made in the same way as one of these disks. Unlike its usual brothers, this one formed in the outer layer of the accretion disk and acts like a wave, moving outward vertically instead of horizontally. This causes the star to dim in a regular pattern every few seconds. Number 6. The Great Attractor. What would a space lift be without a little mystery? This entry will definitely hit the mark, as it is the grand poobah of all unsolved cosmic problems. When scientists looked at the Norma cluster, one of the closest superclusters to us at about 220 million light-years away, they saw something unexpected and, well, confusing. Something called the Great Attractor is pulling galaxies in the area towards it at speeds of more than 200,000 miles per hour with its gravity. Some scientists think that dark energy, the force that is causing the universe to expand, is to blame, because the structure or object would have to have a very large mass to have the appropriate effect on the galaxies. If not, we might be missing important pieces that are needed to figure out how gravity works on a big scale. Number 5. The Sloan Great Wall of Galaxies. When we look at the universe as a whole, we can see that galaxy clusters are made up of many galaxies that are close together. Each galaxy has billions of stars. These groups are divided by spaces that are so huge, it's hard to believe. These structures are called filaments, and there are many of them. One of the largest is called the Sloan Great Wall. This object is more than 1.38 billion light-years long and is about 1 billion light-years away from Earth. The length is especially amazing because it makes up more than 1/60th, or about 5% of the diameter of the universe that can be seen. The part that can be found. The universe is much bigger than that. Even more interesting, this area goes against the general idea that the universe is only 13.7 billion years old, which is the basis of modern cosmology. Many well-known scientists think that it would take between 100 billion and 150 billion years to build and finish such a huge structure. To put it another way, if the Earth took a week to form, the Great Wall would take more than 2 quintillion years. It goes without saying that it's ridiculously big. Number 4. The Eridanus Supervoid. Most of us probably think of space as a place with nothing in it. Most of the time it is. More than 99% of the universe is empty space. This doesn't consider how empty matter is. Once more, atoms are mostly just empty space. But since quantum physics were discovered, we now know that even empty space has tiny amounts of gas, energy, and virtual particles that come and go. So it's still surprising to find parts of space that have almost no stars, planets, galaxies, clusters, interstellar materials, or even dark matter, which we can't see but makes up a lot of the universe's mass. The one in the constellation Eridanus is the biggest of these empty spots. It takes up about the same room as 1 billion light-years. Many scientists have come up with interesting ideas about how this vacuum came to be. One of them thinks that the vacuum is a mark from when our world and a parallel world met a long time ago. Another idea is that the area holds a black hole that is as big as the whole universe. Number 3. Large Quasar Group. The LQG, or Large Quasar Group, is the biggest object we know of in the universe. This part of space is billions of light-years wide and has more than 73 active quasars. Active quasars are usually near active black holes. Some of them can give off more light and energy in 1 second than all of the stars in our galaxy put together. They can be found in many galaxies. This relatively new finding is not only huge, but it also calls into question some deeply held beliefs. Most notably, the cosmological principle. It says that, on a large scale, the world should look the same everywhere. From a cosmic point of view, something this big and unmatched in size is clearly a problem. This is neither the first nor the last finding that shows how little we really know. Number 2. The observable universe. Now comes the part of our list that is really cool but hard to understand. There are 2 parts of the world. The universe that can be seen comes first, then the real world. Both are structures as shown by how the filaments and gaps fit together. We can only see a very small part of the universe because of the way our bodies work. We know that light usually moves at a steady speed through the empty space, so we can't see light from anything past the light horizon, which is the area of space where light from these things can reach us. This area is 13.7 billion light-years across, which is the age of the world. Even though the area is a huge 93 billion light-years across, this is possible because right after the Big Bang, when the universe was only a few billionths of a second old, it started to grow at a very fast rate. This is called inflation. This growth is still going on today, but at a much slower rate. The visible universe has about 10 million superclusters, some of which we looked at today. It also has 350 billion big galaxies like the Milky Way, 25 billion galaxy groups, 7 trillion dwarf galaxies, also called satellite galaxies, and about 30 billion trillion stars. Now, to the last thing on our list. Number 1. The actual universe. First of all, I want to stress that we don't know how big the cosmos is. Many scientists think that the size of our universe is infinite. I won't even talk about the idea that our universe is part of a multiverse with possibly an infinite number of universes. But the truth depends on how space-time is put together as a whole. Even so, the real cosmos has a diameter of at least 14 trillion light-years, some imaginary parts not included. If you take the expected number of stars in each galaxy and multiply it by the number of galaxies in the universe, you can get a good idea of how many stars there are in the whole universe. Due to the growth of the universe, there will come a time in the far future when the part of the universe that we can see will start to shrink before it freezes and disappears forever. Any light from galaxies beyond this so-called light horizon, or the Hubble volume if you prefer, will be too far away and moving too fast to reach us. So yes, even though the universe is getting bigger, it will finally get smaller. The night sky will be dark, featureless, and without anything that makes it stand out. Don't worry though, long before that happens, our sun will turn into a red giant and eat our planet and everyone that is still living at the time. Enjoy your day!